Hi guys, Greenwood Academy has over 10 courses on its training platform. We really wanted to share with you this next video for free to get an idea of what we do day in and day out. Enjoy this roof access solutions for solar installations, cranes, EWPs and more video. Don't forget to like and subscribe and comment on the videos that we're producing, because this gives us an opportunity to continue what we do, and also you get to see what we do on site. So please enjoy this free video download and let's get learning about renewable energy. Hi, I'm Veli from Greenwood Academy. In this training session, we're going to be looking at how to get equipment and personnel onto a commercial solar roof all around a 1 megawatt and a 500 kilowatt case study scenario, and of course, how to get the rubbish down. We're going to be looking at EWPs, cranes lifting a pallet, cranes lifting a glazier's cage, and of course, a solar panel lifter. We're going to go through the pros and cons. We're going to look at risk matrices. We're going to look at costing. We're going to cover the lot. So sit down, get out your pen and pencil, strap yourself in, and let's get into it. Section 1, here we go. As a project manager, site supervisor, one of the most important decisions you'll have to make is how to get materials on and off the roof. And in this scenario, the system is a 1 megawatt commercial solar system, and the roof height is approximately 13 to 14 metres off the ground, and the materials involved are obviously the solar panels, rail and fittings, DC cable and cable tray. Now, if the system has a roof mount inverter station, there's going to be additional equipment that needs to get there as well. This kind of scenario happens to all of us involved in commercial solar systems. How do we actually get that equipment up onto the roof? In this particular training, we're going to talk about quite a few different options, all right? So let's get back to the presentation. Now, we are talking about a 1 megawatt system using 450 watt panels, quite a few of them, 27 to the box. All up, there'll be 83 pallets, boxes to install. And not only that, you must take into consideration that all the rubbish, pallets, packaging must be removed from site as well. This is one thing that a lot of people forget. Materials go up and the rubbish has to come down, and you must factor that into the equation. Let's get back to the presentation. Obviously, the goal is to deposit the materials in such a way that satisfies any financial implications from an equipment hire and installation perspective. As mentioned in this scenario, the system is 1 megawatt and the roof height is 13 to 14 metres off the ground, and the methods we are looking at include an EWP, which is an elevated work platform, a crane with 2 options, other panel lifters. For this example, we will concentrate on the 4 approaches, and they are the EWP, 2x crane options, and a dedicated panel lifter. We will look at the pros and cons and explore what kind of selection criteria you'll need to incorporate when making these kind of decisions. Section 2, getting to the roof. In regard to getting personnel onto the roof, ideally we create a checklist that covers portable scaffolding stair tower, a temporary cage ladder, rope access crew, man basket on telehandler, and we also mentioned the pros and cons and the height limits of these particular approaches. So we've got a bit of a table here, and we'll start off with the method. You're looking at a portable scaffold stair tower, aluminium or steel. The safe height range is up to 20 metres. What kind of licenses? Well, you'll have to look at ASNZ 1576 and obviously do some plant risk assessment, and there's a handover certification required as well. Now the pros: continuous staircase, fatigue friendly, high throughput of workers and tools, and can be left in place for the whole project. But the cons: you need firm level ground and tie-ins. You need to install and remove by a certified scaffolder, and this may obstruct site traffic lanes if applicable. Now the next method is a temporary cage ladder, hooped or vertical, fixed to wall or scaffold. The safe height range is 6 to 11 metres and sometimes up to 15 metres. Key licenses: you'll have to look at AS 1657, fixed ladders, obviously swims and permit to work with all work that we do in the renewable energy area. The pros: look, it's the cheapest hardware option, fast to install, minimum ground footprint. The cons, it's one at a time access, so it really slows the crew's flow down. There's a manual handling of tools and materials, and there's an ergonomic strain climbing 10 plus metres. With all commercial solar projects, there's a lot of physical strain. This is hard work. For anyone who's been on a roof, they know this is hard yakka. Now, the third method is an industrial rope access crew, up to any height, basically up to 60 metres on flat roof. You need a rope access and swims and a rescue plan. The pros, zero ground impact. Great where a crane or EWP is impossible, and it's pretty quick setup and pack down each day. Some of the cons, it's a very low payload, so hand tools only. You need a specialist contractor, and the cost can be anywhere from $85 an hour upwards. Now, the last method we'll look at here is a telehandler with man basket, class 7 telescopic handler. Can go up to 17 metres with a 4-ton telehandler and jib. The licenses, high-risk work licence, and obviously you have to look at AS 1418 and AS 2550. Some of the pros. Look, it combines a material lift and personnel cage in one machine, and good rough terrain reach where an EWP can't reach. Now, the cons of this particular approach is the max basket capacity is 2 to 3 persons plus 250 kilo. You'll need outriggers and traffic management if operating over a driveway. Section 3, the flow chart. So we have looked at personnel accessing the roof, but what about materials such as the panels, the rail, and all the accessories, and of course the cable? We need to ask some questions. Is one piece of equipment even suitable to transport all the different materials? For example, is it really such a good idea to load rail onto a panel lifter? And what about the DC cable? Those drums can be pretty heavy. Also, if there's an inverter station on the roof, a panel lifter won't cope with the heavier components. As well as materials, people need to get to the roof. So do we use an option that can allow both people and machinery to access the installation site? Now, crane is out of the question. So is a panel lifter. What about an EWP? There's a fair bit of equipment and rubbish, not to mention people that need to come off the roof. With a crane lift, all the empty pallets and the cardboard needs to come down. Now, does the crane stay on site until finish, or is there a second appointment? Maybe it's a mix of equipment. Crane lift first, EWP second. There's so many questions. We'll have to delve a bit deeper into this project and ask the following questions around people and materials. For example, can personnel access the roof internally? If answer is yes, then equipment required for personnel movement is not needed on an ongoing basis. I'm sort of going through a pretty obvious step by step, but this is really the way you should be breaking down any process and procedure and approaching it from a yes-no perspective. And that way you can actually get to the crux of the matter pretty quickly. Pretty long-winded, sorry about that. Let's get back to the presentation. Can use crane exclusively, full pallets or a cage approach, and can use crane or panel lifter theoretically. Can still use an EWP, but just for materials, not people. Now, for example, can personnel access the roof internally? If the answer now is no, well, an EWP or similar must be part of the equation, by itself or with a crane. Before we dive into the pros and cons of the various methods available to us, let's have a look at a simple decision flow chart that starts with one question. Is there internal roof access for personnel? If yes, only materials need lifting. Is a crane feasible? Space permits budget? If the answer is yes, then a crane and cage is an option. If the answer is no, then you'll have to look at an EWP or a panel lifter. If we go right back to that initial question, internal roof access for personnel, no, there's no access. So what do? We need to lift materials and people. Now, an EWP, is it feasible? Ground height budget? If yes, EWP and materials. If no, hybrid, temporary stairs, panel lifter and or crane. by creating this simple flow chart before the project comes anywhere near setting boots on the roof. Go through that process, find out what is the best approach for this particular project in question. Let's get back to the presentation. EWP, the pros. An elevated work platform is effectively a motorised scissor lift that can be positioned and is used to transport materials to the roof. Now the pros, it can be positioned with a fair degree of accuracy depending on the site characteristics. Potentially can be moved more easily to different parts of the site, ensuring even panel placement. Easier site access, smaller, say more manoeuvrable than a crane. Lower risk of accidents potentially due to the nature of the beast. Now compared to a crane, an EWP has a smaller footprint with all the advantages that this entails, so maybe it is a deciding factor depending on the actual site itself. Now in a lot of cases, these sites have space constraints, and that may not be apparent on your site visit, but funnily enough, when these projects start, suddenly these sites become a hive of activity, not only for what you're doing, but what the actual business is doing. Suddenly that clear access is filled with pallets of whatever or equipment for the particular site in question. Yeah, these are the things you have to take into consideration. Let's get back to the presentation. Due to its smaller size, there are other pros compared to the large crane option that should be taken into consideration. Smaller machinery, less overall emissions. Potentially more suitable for projects that require an increased environmental consideration compared to a crane. Stakeholders may have objections to a crane due to specific site characteristics. In this age of environmentally conscious decisions, the perceived advantages of an EWP must be considered, but if your initial proposal does not cater for changes in this area, e.g. your costs are based on a crane lift, but the customer's demanded this after the fact, then basically it's a variation. And we all love variations. Obviously, cost is a key consideration, and all assessments on a project's worth revolve around cost. Some more pros. It's cheaper than a crane in most cases on a per day basis. Long term though, that's questionable. In-house team with qualifications can operate, so that's always good. An EWP is definitely cheaper than a crane based on hourly, weekly rates, but it comes down to total costs, including time on site and labour. Now, whether it's an EWP or crane, there's a considerable amount of documentation required. Pros. There's less overall documentation than, say, a crane. Most likely there's no need for a traffic management plan. It's not as heavy as a large crane, so underground assessments due to excessive weight on the road probably not needed. There are exceptions though. Crane lifts require a huge amount of planning, organisation, documentation and finger crossing compared to what is required for an EWP. Now, always have a checklist. So document whether it's a crane, EWP, panel lift or a forklift. You're looking at swims, lift plan, traffic management plan, council road reserve permits, power line exclusion zone calcs, plant risk assessment, and daily pre-start log. Always remember your checklist. So we've talked about all the pros for an EWP. Now let's get stuck into the cons. Some of the cons include internal in-house training will be required. Definitely, you'll need a license. May need to train at least 2 personnel. Redundancy. Operational processes and procedures will need to be developed in-house. Note, if using a crane, all the onus is on the crane operator from a liability perspective, but not with an EWP. Now, that could be a real deciding factor when it comes to your decision-making process based on a whole, set of selection criteria. But each project's completely different, so you have to make that assessment effectively on what the site characteristics are, what are the expectations of the stakeholder, what about the cost considerations, obviously, because it's all revolving around the total project cost, and a few other factors that we'll look at later on. Let's get back to it. If selecting an EWP, the time on site is considerably longer than if the crane option was selected. So An EWP is longer on site, so potentially there's a chance of vandalism. Look, vandalism does happen on site as well as theft, and it's something you must take into consideration with any project you're doing. Any damage to the side of the building when operating an EWP, you're liable. And you'll need to be responsible for fuel. A crane lift can achieve its objective possibly in 2 to 3 days compared to an EWP long-term on site. So higher chances of vandalism, theft, insurance implications all play a role. Now, gone are the days of smaller footprint panels and reduced pallet weights. And now a full pallet cannot be accommodated by even a large EWP at this point in time. So the cons. Panels need to be removed from boxes. Cables clipped on ground, double handling before loaded. You're limited to weight capacity regarding the number of panels placed on the EWP. And you have to factor in road conditions, gravel, sloping may mean EWP may have stability issues when setting up. And when the panels reach the roof, there must be the right number of personnel there to unload. As panels are getting bigger and the pallet's weight and dimensions have increased, preparation usually occurs on the ground, and then the pre-clipped panel is placed inside the EWP and then individually removed and either installed or placed at various points and temporarily secured. This can be a real issue. You must take into consideration that when you're clipping these panels before they go onto an EWP, where are they being held? Are you leaning them up against a wall, or are you clipping them and one by one they're getting loaded? So these are things you have to discuss with your team well before the project starts. Let's get back to the training. Now, we're still looking at the cons of using an EWP for moving equipment materials to the roof. EWP may take longer, whereas a crane can speed up the process. Well, that's stating the obvious. If timelines for installation are tight, it may not be the best option. More time on the roof, more chances of any OH&S issues. At the end of the day, using a crane to lift rail materials and panels is quicker, but this comes at a price. We're now looking at the pros for moving equipment, material to the roof using a hired, suitably sized crane. Pros: rapid material movement to the roof. Obviously, cranes are a lot faster once they're set up, but you have to take into consideration how many times are they going to be moved. Potentially allows for quicker installation due to the crane lifting capacity, full pallets. Ideal for large-scale projects with really tight timelines. In some cases, the EWP cannot get close enough to the building, whereas a crane doesn't actually need to. Predetermined drop points can shorten the overall install time. That's debatable depending on how long it takes to set up the crane, how far it has to travel to its next point, its next drop point, and does the site allow for transportation and movement of the crane? Whereas, because we know on these sites lots of other things are happening, and a lot of things, or most things, that you can't control. Let's get back to it. Less double handling of panels, time saving. Well, this is the thing, isn't it? When you actually use a crane, you're taking that full load of panels up onto the roof. But once that panel's open, they have to be clipped up there and then deposited where they need to be. These are all things you need to consider. Effectively, the main advantage of a crane lift over an EWP is time taken to get the panels and equipment to the roof. End of story. We are now looking at the cons for moving equipment material to the roof using a hired, suitably sized crane. Cons: considerably more documentation needed than for an EWP. You may need road traffic control and additional permits, especially for large cranes. Large cranes weigh a lot, possibly issues with below-ground infrastructure impact. The requirement for an accurate SWIMS modification is high, and the sheer amount and detail, if utilising a large crane, is massive. Again, let's go to the checklist. Document, SWIMS, lift plan, traffic management plan, permits, power line exclusion zone, plant risk assessment, daily pre-start log for a crane, EWP, panel lifter, and the forklift. Because we have to remember that no matter what method we use to bring the equipment to the roof, we also need machinery to bring the equipment to the point where it's being lifted from the ground onto the roof or onto other equipment, and that's a forklift. If there is a need for an extremely long reach, then the size of the crane increases considerably. Site access issues if the crane is very large. Can it get in at all? I mean, don't laugh. There has been incorrectly made site assessments that said, yeah, we can get a 200-ton crane in or 100-ton crane in, but no. In some cases, you can get the crane in, but when it comes to manoeuvring on site, no, crane has to come out and another method has to be looked at. It's happened. Can crane access several sections of the site to deposit at multiple drop points? So that's site logistics. Roof structure must be assessed for structural integrity, potentially adding time and cost to the project. Now, we all know about engineering structural assessments of roofs, whether they can cope with the panels, but point loading with a pallet, a full pallet of panels, requires an additional assessment that comes at an additional cost. And by the way, not all roofs can cope with the full weight of a full pallet of 500 plus watt panels. Determining multiple drop points on the roof requires a lot of time and energy concerning access, structural integrity, site infrastructure that may impede crane movement. Danger to personnel and stakeholders all must be taken into consideration. Now, initial cost is the main con when comparing the crane approach and the EWP approach. So initial crane rental and setup costs can be substantial. All panels and equipment must be organised to be delivered over 1 to 3 days, and this has financial implications. Is there a space to store all the equipment coming in a short space of time? Again, don't laugh. This happens all the time. You've allocated an area on site for the pallets. The problem is you haven't got any authorisation from the stakeholders to say, yes, this site will be vacant and empty for your pallets on this day. There's no sign, there's no bit of paper. And then, unfortunately, you've organised everything, you go to site and suddenly there's stuff everywhere. Again, attention to detail. Make sure that when it comes to where you're going to be storing equipment or even equipment that's there for a very short space of time, get it signed off by the stakeholder. May produce more emissions from an environmental perspective. From a costing perspective, still have to take into account that the panels need to be installed. Because remember, we're carrying full pallets up onto the roof. The pallet hasn't been opened, nothing. So with an EWP, obviously, in most cases, you're cable clipping on the ground, you're taking them out of the pallet, you're loading onto the EWP, they go onto the roof, and ideally they get deposited in situ as they come up. And of course, all the panel rubbish and all the rail rubbish and all the other rubbish needs to be removed. If cash flow is an issue, the huge cost of a large crane over 2 to 3 days, combined with organising all the roof equipment to be ready to go, may be a deciding factor. Now, crane with glazier's cage. Now, this is a setup where a crane is using a glazier's cage and can hold 7 or 8 panels. The cage actually doesn't sit on the roof, so there's no point loading like a standard crane lifting a pallet, but you'll need personnel to unload that glazier's cage quickly and send the crane down for another load to come up. All things to consider. There is a variation on the standard crane pallet lift, and that is incorporating a glazier's cage. Now, the pros is no need for full pallet load structural reports from the engineers. If you have the personnel ready, installation can be pretty rapid. With a long reach crane, panels can be brought closer to the final resting place. Now, this is an interesting use of the crane, but it really relies on having plenty of willing hands ready to install the panels quickly, as with the EWP approach. All the same as the standard crane lift without the roof structural integrity requirements. Panels are ideally clipped on the ground as with the EWP, and there can be some issues there. We'll need plenty of workers loading and unloading the cage. Now, panel lifters have been used on smaller commercial projects and some domestic, and they can be advantageous. They do have some pros and quite a few cons, and we'll discuss those. So let's Let's get stuck into the pros of a panel lifter. This is the fourth option, and in most cases, it's the slowest delivery method. Now, pros, it can be positioned with a fair degree of accuracy depending on site characteristics. Can be moved more easily to different parts of the site, ensuring even panel placement. Obviously, easier site access, small, it's more manoeuvrable. Now, obviously, cost is a key consideration, and all assessments on a project's worth revolve around cost, as I keep on going on and on. But it's true, we're talking about commercial solar. The drivers are purely financial, number 1 and 2 and 3, and maybe even 4 and 5 and 6. Obviously cheaper than a crane or EWP in most cases on a per-day basis. Long term though, who knows, debatable. You'll need an in-house team with qualifications to operate. Due to its smaller size, there are other pros compared to the large crane or EWP option that should be taken into consideration. It's smaller, so there's obviously a lot less emissions, potentially more suitable for projects that require an increased environmental consideration. And stakeholders may have objections to a crane or EWP, but not a panel lifter. But if you've costed your project based on an EWP or a crane and suddenly the stakeholder says, I want a panel lifter, I don't want an EWP or a crane on my site. If the panel lifter option is more expensive, and even if it isn't, this is a variation, you should charge accordingly. Make sure your contract takes those things into consideration. Variations are very, very important. Let's get back to it. Pros, less overall documentation required, if any documentation. Most likely no need for a traffic management plan. Not as heavy as a large crane or an EWP, so there's no underground assessment due to excessive weight on the road. Not needed at all. Again, consult the checklist. The document, SWIMS, lift plan, traffic management plan, permits, power line exclusion, zone calcs, plant risk assessment, and daily pre-start logs for the crane/EWP, panel lifter, and forklift. Now, we've covered most of the pros, so now it's time to look at the cons if using a panel lifter for moving equipment, material to the roof. Cons. Internal in-house training will be required. May need to train at least 3 to 4 personnel. Redundancy. Operational processes and procedures will need to be developed in-house. And can it lift heavy cable drums? Debatable. If selecting a panel lift, the time on site is considerably longer than if the crane or EWP option was selected. So, panel lifter longer on site, potential chance of vandalism or threat, unless it's packed down at the end of every day. Any damage to the side of building when operating the panel lifter, you are liable. And there's a possibility of having to set up and dismantle time and time again. True, obviously, if you are depositing the panels at various points. So you can imagine, like on a really big job, you're talking some of these roofs are 200 metres long by 100 metres wide. You're not going to set up your panel lifter in one spot. You're going to probably go to maybe 4 or 5, maybe even 6 points, depending on the planning and depending on what you've decided. You'll need to access 240 or 230 volt AC extension cords unless it's genset driven. And you'll need the full install team ready to go to install the panels. And some roofs are very high, so will the panel lifter get to the top? Rise over run issues with space needed. No matter what method we finally choose, a forklift will be required to position the pallets at the selected locations. We'll have to consider the following. What kind of forklift? Electric, LPG or diesel? Will it need all-terrain tyres or not? How long will it be needed on site? How much discount is there for long-term hire? Who will be driving the forklift, and do they have a forklift licence and experience? As we are talking about a 1 megawatt system using 450 watt panels, 27 to the box, all up there will be 83 pallets boxes to install. And not only that, you must take into consideration that all the rubbish, pallets, packaging must be removed from site as well. So what options to select? Let's look at some indicative costs first. So you're looking at a crane truck, 100 tonne. So the counterweight, delivery and a pickup fee, you're looking at $800. Doggers, riggers, cost per hour is $250. Hourly rate of $400 for the crane. Daily rate with a dogger and rigger, $5,200. Total daily rate and delivery and pickup, $6,000. Weekly rate, let's say $12,000. Total weekly rate and delivery and pickup, a little over $14,000. Monthly rate, $36,000. Total monthly rate, delivery and pickup, you're looking at $36,800. Crane truck, 100 tonne with a cage, so that's a little bit more. So the counterweight and delivery and pickup fee, $1,400. Doggers, riggers, etc., still $250. Hourly rate $400. Daily rate still $5,200. Total daily rate with delivery and pickup $6.6K. Weekly $12,000. Total weekly a little over $14,000, so about $600 more than the standard crane rate. Monthly rate's going to be about the same, and the total monthly rate plus delivery and pickup a little bit more, but at $37K. Now, when we look at an EWP, we're looking at a 16.1 metre diesel rough terrain scissor lift. You're looking at a delivery fee of $580. There's no doggers and riggers. There's no hourly rate really, but the daily rate is $500. The total daily rate, delivery and pickup is $1,080. Weekly rate maybe $1,800 if you can negotiate. Total weekly rate and delivery and pickup $2,380. Monthly rate $5,000, and all up monthly rate with delivery and pickup $5,580. Now the last one is a solar panel lifter, so maybe it's a $20 delivery charge. No doggers and riggers, hourly rate, none of that. Daily rate $200. Looking at $220 for the next category. Weekly $800. Total weekly plus delivery and pickup $820. Monthly rate $2,700, and total monthly rate delivery and pickup say $2,720. So considerably the cheapest by a long way, obviously. Now the forklift, you're looking at $350 delivery, $160 per day, $510 plus daily rate plus delivery. Weekly you're looking at $380, but total weekly rate and delivery and pickup $730, monthly rate $2,100, and $2.4K for total monthly rate delivery and pickup. Okay, we seem to have most of the information, so let's go through the process of making an actual decision about what we're going to use on this particular project. Let's look at crane costs, and we'll make a few assumptions concerning this 1 megawatt project and where the panels are going. We're going to consult a structural engineer who will ascertain where on the roof pallets can be positioned. And once this is established, conversations and a site visit is conducted with the crane business. They go back, they do their magic and produce the correct option. In this case, it's a 100-tonne crane truck. Now, because we want to maximise the position of the pallets in relation to their final resting place, we have selected 2x primary drop points on the roof. This means 2x crane position shifts, the original setup plus the second position setup. In reality, there's actually 4 drop points, but the crane has 2 positions, and it will swing from left 1, 2, and then on the other side of the roof, 1, 2, so 4 actual drop points. Each spot requires 42 by individual 680 to 700 kilo pallet lifts. And we've allocated 3 full days on site, but is this accurate? This equates to 24 hours in which time 83 pallets need to be positioned. The whole issue with a crane lift is that everything has to be ready in a fairly short time period due to the enormous cost of the crane itself. 42 pallets have to be positioned, as mentioned, at each of the 2 sites. Does the site have the room for this? We'll need to make sure you have a forklift working hard over the next 3 days. Cranes should be lifting on average around 3 to 4 pallets per hour. And then you got to add in position changes, and you're basically looking at 3 to 4 days, especially with a large site where the building area is around 20,000 metres squared. So in other words, 100 metres wide and 200 metres long. And this is just for the panels themselves. Because remember, there's the rail, the DC cable, there's all the rail components and additional equipment that's required on the roof. Let's do some approximate costing that takes into consideration the following assumptions. Crane hire for 3 days, dogger, rigger looking around 18 grand, including GST. Will require a forklift on site to move pallets into position, 3 days, so 913 including GIST. Traffic management, maybe, 2 by traffic controllers. The ute is $80 to $90 per hour, say 8 by hour, so that's $800 a day, including GST. So you're looking at a little over 21 grand for this exercise if we include the traffic management component. And this doesn't consider all the administration side of things. And of course, what about the rail, cable, all the empty pallets, packaging rubbish that needs to come down off the roof at the end of the project? With the crane costing, we can look at another scenario that will reduce the overall cost, 2 by days on site. The 2-day scenario means the costs are as follows. Crane cost is $12K. Assumes 40 plus lifts a day, so approximately 5 an hour. Forklift only needed for 2 days, little over $700. Traffic management just for 8 hours, that's $800, all up nearly 14 grand. Note, is 2 days realistic for 83 lifts for the panels? And also we can't forget the rail and other associated equipment that needs to get to the roof. And here's a work safe plan of the no-go zone. Spot is required, and this is an exclusion zone around power poles. If using an EWP, we're talking about a longer time period without the immediacy that is needed if using a crane. Let's assume we need the EWP over a 5-month period, on the assumption that the whole job will take 3,500 personnel hours, working 7.5 hours a day, 9 days per fortnight. Let's throw in, let's say 4 by public holidays. So total work days is 86 times 7.5, 645 hours per person. So we'll need 3,500 divided by 645. You're looking at a consistent 6 by persons on the job for the entirety of the project. And that's probably not being that conservative. Note, the reality is that the number of personnel will vary depending on the tasks undertaken. Let's look at the cost for the EWP for the time in question and the fact that you will need a forklift for a certain percentage of the time on site. Now, we're going to get a discount on the EWP as we're looking at a monthly hire. Let's say we use the EWP for a total of 4 months over the 5-month period. Also, we'll need the forklift over multiple periods. Now, the issue when using the EWP is trying to minimise the overall hire cost whilst trying to schedule when the EWP will actually be needed and then coordinating personnel in conjunction with the forklift which will be needed to move the pallets around. High costs based on month-long hire periods will allow a business to negotiate better terms, but what also must be taken into consideration is the availability of the EWP as well when actually needed. And this is an issue that all companies have come across when they're doing multiple projects. They've gone to hire an EWP. Sometimes they've hired one without an all-terrain wheels and the site requires all-terrain wheels, and suddenly they go, well, okay, well, let's get rid of the standard EWP. Let's get one with all-terrain wheels. By the way, they're all hired and none will be available for the next 2 months. You really got to plan. Plan. The more planning you do before the project starts, the better. Let's get back to the training. Equipment, EWP costs. So we're looking, the method is an EWP, 16.1 metre, diesel, rough terrain, scissor lift. Time period needed on site in months. How many months? 5. It's going to cost 17 grand. Counterweight delivery pickup, $700. Total $17,700. Add GST, 19.5K. Now, what about the weather? This is something that a lot of people don't take into consideration when it comes to machinery. They do with people because obviously there's wet days and wet day work. But what about if you've pre-hired an EWP or crane and suddenly the weather starts turning nasty? What are you going to do? When dealing with large machinery, there are all these other factors that can affect the financial viability of the project and must be taken into consideration. And one of them is the weather. For example, a crane lift. And this will require putting together a weather risk matrix. Now, it sounds more complicated than it is. Just bear with me and we'll go through the process. So effectively, a weather risk matrix can take the form of a table. And you've got headings such as machine access method, the wind rating in kilometres, the typical stop work trigger, the downtime cost, lost days in Australian dollars, and a mitigation toolbox. So we're looking at a 100-tonne all-terrain crane, full pallets, or with glazier cage. So you're looking at 36 kilometres per hour. Now, the typical stop work trigger is sustained greater than 35 kilometres or lightning that's less than 10 kilometres away. Now, these will stop. This is a typical stop work trigger. So downtime cost, you can anywhere between $7,000 and $9,000 a day. The mitigation toolbox, early morning lift window, standby rate, 40%, stage pallets near the edge. Now an EWP, wind rating, it's got a pretty good wind rating at 45 Ks, gusts of greater than 40 kilometres, heavy rain, soft ground. You're looking at $2,000 to $3,400 downtime per day, and the mitigation toolbox is work leeward bay, stockpile on roof during calm, and use mats for stability. The next is a panel lifter or a solar hoist. Wind rating maybe 32 Ks per hour. Typical stop work trigger. Hoist away greater than 25 kilometre gusts. Maybe $1,500 to $2,000 per day. Probably less than that, I'd say. Mitigation toolbox, windbreak tarps, manual rope for singles, flexible delivery slots. Telehandler and man basket, don't really like this option, but I'll put it here anyway. 28 Ks is the wind rating, gusts of greater than 25 Ks or greater than 60% boom, $3,000 to $4,000 a day. So the mitigation toolbox is fit jib winch, night dawn calm runs, minimise outreach and guide with rope. The night dawn calm runs will depend obviously on the site and obviously the noise restrictions from the what are the regulations around noise restrictions and working on site in that particular council area. Now the last one is a 3-tonne all-terrain forklift. Obviously now it doesn't really have a wind rating because it's terrestrial based, it's on the ground. Typical stop work trigger, ground bog, rain, wind rarely governed, so basically boggy ground and rain. $800 to $1,200 a day lost. And so from a mitigation toolbox perspective, look at steel road plates on soft yard, store pallets under cover until crane window if using a crane. And that's a bit of a Gantt snippet to give you an idea of what it would look like with a delay ripple, crane delay ripple with EWP and schedule. What about the waste? Yes, now we come to the dirty side of these projects. All the waste, how much there is, what do you do with it, how quickly you get off the site, what is your waste management strategy? Let's get stuck into it. As well as having to calculate the actual personnel and materials getting onto the roof, there's also a question around waste removal. If using an EWP, there's going to be less roof waste because there's no actual pallets. A crane with a glazier's cage falls into the same category waste-wise as an EWP, but a straight crane lift involves the most waste, pallets and packaging. So let's look at the waste volume breakdown. So wooden pallets in most cases on a 1 megawatt rooftop install, and you're looking at a total of about 26 cubic metres of waste. They account for a little over 57% of all the waste. The cardboard packaging about 30.8%, and cable drums 11.5%. So that's a pretty, it's not exact for all projects, but it's pretty standard. So now we're going to look at the waste stream and volumes. So we've got a little table set up here. The waste stream is the wooden pallets. We're looking at 83 full panel pallets. The estimated volume in cubic metres is 15. The density, kilograms per cubic metre, 250. Reuse, recycle note, 100% reusable. Pallet recycler pays $2 each. Yeah, if you can find one to pay that amount. Just depends on the kind of pallet. But do consider them to be a resource. And ideally it'd be great if they can come and pick them up as well. Cardboard packaging, So you're looking, again, 83 panels, cartons and peripheral boxes. That's about 8 cubic metres. A density of, it's quite a low density compared to the pallets, 75 kilograms per cubic metre. Bale and send to cardboard recycler. That's one thing. Don't commingle your waste on these projects, especially, it's good practice from a sustainability perspective, but also as the jobs are getting bigger and people, some of your clients are looking at the carbon accounting, scope 1, 2 and 3, it may be a requirement that you do bale and send to the cardboard recycler as part of your contractual agreement. So just be careful on this one and do the right thing. Cable drums. 6 by 500 metre drums, could be more depending on the cabling configuration. 3 cubic metres. Density 500 kilograms per metre cube, timber and steel. And if you can, return to the cable supplier for a rebate. Now that would be great. Now we've got another little table here. So we've got option, gear on site, cycle time, labour and likely schedule impact. Let's look at the skip bin crane to a roof. Now this is a bit severe, but it is an option. So you'll need a 15 metre cube hooked lift to skip, and that's a hard one to say. Crane returns for a 2-hour pickup. You need a spreader and skip lifting lugs. Cycle time, 1 day to fill during install. Labour, 2 roof and 1 on the ground. Likely schedule impact. Allow a half-day crane standby, which avoids double handling. 2, enclosed rubbish chute, roof and skip at ground. This is an interesting option that I've actually never seen on a commercial solar project, and maybe for good reason, but I thought I'd add it in here just as an option to potentially consider. 20 metre chute section, 15 metre cubed skip at the ground, on the ground. 6-hour install, then live for duration. 2 installs for the chute. Crew drop waste anytime. So the likely scheduled impact is to keep the roof clear, and the cardboard may jam and you'll have to monitor that. The next option is backload an EWP after each lift. Existing 53-foot scissor and a bulk bag for the cardboard. That's the gear on site that you'll need. Cycle time is, 6 to 8 minutes per EWP cycle. And the labour is the same 2-man EWP crew, and you'll have to add 1 extra day across the project, but no crane return. Now, forklift, shuttle and ground skip. 3-tonne all-terrain forklift, 15 cubic metre skip at laydown, 2 minutes per fork shuttle, fork driver only from the labour perspective, and likely schedule impact works if internal, stair, EWP for roof crew, pallets remain whole. So there's a few options there. Now we're going to look at a hybrid plan. So the recommended hybrid plan is, and the heading on this table is as follows: phase, equipment, action and time. Panel lift days, crane on site. Equipment, crane, 15 cubic metre skip near crane, pads. Drop empty pallets straight into skip via crane spreader. Cuts pallet handling by 50%. Time, 3 hours for the crane hire. Let's look at install weeks. Equipment, EWP with bulk bag, baled cardboard press at the ground. Action, cardboard backload each EWP descent, bag swap daily, and you're looking at 5 to 10 minutes per day. Post-install clean down. Forklift, hook lift skip, retrieve stray pallets, load cable cores, final roof sweep, half a day. That's a hybrid approach that we've looked at to remove the waste from these particular projects. Now let's look at section 18, the waste removal checklist. Key equipment checklist. So this is another table. We've got item, quantity, hire rate and notes. A 15 metre cubed hook lift skip, 1 to 2 of them. You're looking at $350 a week, and you can book a swap out the day before the crane demobilisation. Skip lifting spreader bar, you'll need 1 of them, $120 a day, and the notes, you need crane certified. Enclosed rubbish chute, 20 metre. There's 1 kit, $650 a week, so that's not too bad, I'd say. And notes, you'll need scaffold tied off, points required. Bulk mesh bag, 1 metre cubed. You need 5 of them, $15 each, and they're reusable cardboard plastic wrap. Pallet stack brackets, 2 of them. No high rate from them. Fabricate from scrap, unistrut, bolt to skip rim. So that's something that you put together yourself. Forklift tipping bin, 1 cubic metre. You need 1 of them, $40 a week, optional if no chute. Now we're going to talk a little bit about sustainability. This is becoming more and more important as time goes on. A lot of the larger businesses out there are looking at their environmental social governance. They're already starting to calculate scope 1 and 2 from a carbon accounting perspective, and they will also expect, in most cases, that their contractors follow certain checklists and certain processes and procedures so that their activity aligns with the customer's activity. So let's get back to the training. Now, does sustainability matter? This is an interesting question, and the answer may determine your particular approach. Note, if you have factored in cost-wise a particular method and then the client asks for a more environmental friendly approach, which costs more, this is a variation and should be charged as such. Remember, variations are very important. Now we're going to look at a sustainability scorecard, roof access in a table format. So we've got a little table with method, the diesel litre per tonne lifted, the CO2 per kilogram per tonne, the noise, the relative speed, the sustainability rank, the 1 being the best and 10 being the worst. First off, the rank is a 100-tonne mobile crane with full pallets. You're looking at 3 litres per tonne lifted. You're looking at 8.04 CO2 per kilogram per tonne, 85 dB. Now remember, decibels is logarithmic, so the difference between 80 dB and 85 is considerable. Relative speed, it's the fastest. We know that it's the fastest. And its sustainability rank is 3. Now, 100-tonne mobile crane and glaziers cage, you're using a little bit less fuel because you're not lifting as heavy a weight. And the CO2 kilograms per tonne is 6.7. The noise is 84. It's fast, but not the fastest, but it has a better sustainability rank too. Diesel, 53-foot EWP, 14 litres per tonne. CO2, 37.52. Noise, 80, so it's the quietest of the 3. It's quite slow. Not the best on the sustainability rank with a 4. Electric panel lifter, winch, 0 diesel litre per tonne because it's using electricity, unless it's genset driven. 1.5 kilograms of CO2 per tonne. Noise, 70, very slow, but it gets number 1 on the sustainability rank. Diesel forklift ground move, 0.67, 1.7956. Boy, there's a lot of decimal points. I should have cut that one down. Noise, 82. It's fairly noisy. Relative speed, not applicable here, and it gets a sustainability rank of 2. Your next big project may not require you to do that assessment, but it's good practice to actually have it there. And also it might be a selling point when you're talking to customers that you actually are ranking the methods that you use and giving them, putting them in using a sustainability index. And it will become more and more important as time goes on. We're looking at a 500 kilowatt case study here. Client is a regional supermarket, 500 kilowatt rooftop PV, has a roof height of 13 metres, tilt panel parapet, no internal ladder or stair access. Okay, so there's no personnel accessing the roof internally. The footprint is 5,000 metres squared, metal deck, and it has multiple HVAC penetrations. The construction window is 10 weeks, night and weekend noise limits. The stakeholder drivers, keep loading dock clear, minimise street closure, hit ESG targets. Now, I mentioned about ESG, environmental social governance. This is something that the supermarkets do look at and take that into consideration because we're going to see more and more of it, okay? It's not going the other way. Let's get back to it. Now, we're looking first at a 90 to 100-tonne crane. Fast bulk pallet drops, full panel crates, requires 2-day road closure, traffic management council permits, ground bearing analysis, flagged sewer easement risk. We'll then look at a crane and glaziers cage, lighter roof point loads, but still street closure, permit still required. We'll need 6 to 8 staff on roof for each lift. 53-foot rough terrain scissor EWP, and that's the chosen. Fits in rear delivery bay, zero impact to main road, can lift small panel bundles plus rail plus cable drums. Operable by in-house crew, repositioned along facade as build advances. Panel lifter is also an option, but too slow for the 500 kilowatt schedule. Execution highlights, EWP approach. Sequential facade zoning, moved EWP every 30 metres, kept pallets within 15 metres of the install team. Panel prep on ground, unboxed and clipped. This reduces roof clutter. Forklift, electric, shuttled rail and panel bundles to EWP deck. Daily swims updates, no street closures, positive stakeholder feedback. Yay! Zero manual handling injuries, 100% LTI free build. And LTI is lost time injury. Now, LTI is any work-related incident that result in a worker being unable to perform their normal duties for at least one full shift working day after the event. So 100% LTI free build means the project recorded no incidents that cause lost work time. And that's a strong safety indicator alongside zero manual handling injuries. Near misses is another thing, and I urge you to actually record those because it does help improve your processes and procedures. And at the end of the day, we all want all our personnel to go home to their loved ones. Let's get back to the training. Execution highlights, EWP approach. Sustainability and the community wins. The diesel burned 30% less than the crane scenario because we had lower idling hours. The CO2 avoided 1.7 tonnes over project compared with the crane plan. Noise kept to less than 80 decibels at property line, compliant with council limits. Supermarket remained fully operational, no delivery dock shutdowns. A great media piece in the local paper on quiet solar install. Now, section 20, lessons learnt and next steps. For a less than 700 kilowatt roof without internal access, extended hire EWP can beat crane on total cost and ESG despite the slower pace. Early ground bearing check can eliminate heavy lift options before design freeze. Built-in buffer days, wind gusts greater than 40 kilometres an hour, grounded EWP twice. Schedule padding is always essential. Future upgrade, battery retrofit will reuse same rear bay EWP method. Template scorecard now included in Greenwood's Access Planning Toolkit for all commercial bids. Any documentation you produce is always going to be improved. Each time you do a project, you should always be looking at how can we do that better? How can we make the documentation better? How can we improve from an installation perspective? Constant improvement should always be the goal. So let's have a look at a cost comparison, crane versus EWP. We've got the equipment hire, so 90-tonne crane, 3 days, 18K, EWP 10 weeks, 22K. Traffic management permits, 8K, 0 for the EWP. Under road engineering review, 3K, nothing for the EWP. Total access budget is 29K for the crane, 22K for EWP. Schedule impact, 3-day lift, 6-week install, and for the EWP it's a 10-week install, and they did allow 10 weeks, the stakeholder. The ESG score for CO2 per tonne lifted, total of 7.5 kilogram for the crane and 2.1 kilogram for the EWP. I've put together a 10-point step-by-step plan for roof access assessment. So let's have a look at it. The main column headings are phase, the main step, and the key sub-steps and checks. So phase 1, the project's 1, so we confirm contract scope and delivery window. We populate the project sheet with the roof height, array size, panel, pallet count, racking length, cable drums, and inverter skids. We nominate an internal PM, safety lead, and logistics lead. Phase 2, site access assessment. Personnel access, verify internal stairs, service lift if none, flag external access. EWP, temporary stair, tower, telehandler, man basket. Material access, measure clear set down zones, parapet height, street frontage width, underground services, ground bearing limit. Photograph roof obstructions, power lines, fire, egress routes, etc. Phase 3, method shortlist. Pre-fill comparison matrix, crane and cage, 53-foot scissor EWP, panel lifter and hybrid. Pull 3 quote equipment rates and traffic control rates, local 2025 in Australian dollars, cross-check ESG targets and include a sustainability scorecard column. Phase 4, decision gate. Scorecard options against 5 criteria. Number 1 is schedule impact, 2 total cost, hire permits and engineering, 3 roof load limits, 4 crew ergonomics and safety, 5 community traffic impact, and then whole client and HSEQ sign-off meeting document selected method. Phase 5, documentation package. And you're looking to update the SWIMs, the lift plan, the traffic management plan, the power line exclusion calcs, lodge council or Vic Road permits if required, book engineers, roof point load, cert or a sewer assessment sign-off. File regulatory checklist, material lift and personal access in Project Drive. Phase 6, pre-mobilisation logistics. Lock equipment dates, raise the POs, confirm forklift specs and hire length, all-terrain, electric. Sequence panel and rail deliveries to align with chosen methods, example, staggered pallets for EWP. Order waste removal skips and shoot backload plan. Number 7, site setup. Toolbox talk. Day 1, review lift plan, weather risk table, exclusion zones, installing the edge protection, temporary access towers or landing platforms as required. Mark EWP, crane pads, verify no underground clashes. Very important. Number 8, execution and monitoring. Follow the Gantt snippet, forklift, lift, roof install, waste offload. Record daily panels lifted per worker. Update ergonomic log. Track wind and forecast. Reschedule lifts if they're greater than 40k high wind gusts. Daily safety walk. Capture LTIs. Target is 0 always. Phase 9, closeout. Remove equipment. Final roof inspection for damage. Take drone photos for as-built record. Complete waste removal, tally and ESG scorecard. Collate permits, close, cert signed, roof engineer, traffic authority, etc. Number 10, lessons learnt loop. Hold a 30-minute crew debrief. What slowed down lifts, what saved time. Update comparison matrix with actual dollars and hours and archive docs and flowchart for next bid. Send highlight reels to marketing. Very important. We hope you find this training presentation valuable and we can't wait to hear about your next project where you apply what you learned here in the real world on your next commercial solar job. Stay tuned for more practical training and see you next time. The Greenwood Academy team. Thanks so much for watching this training presentation where we looked at that age-old problem of how to get equipment and personnel up onto a roof and all the rubbish back down. We really hope that you incorporate some of the processes and procedures and concepts that we've explored during this session. And please tell us about your next commercial solar project. We'd love to hear about it. And also, for any other training ideas, send me an email. See you in the next training.